Hello Huskies, let's talk about features of functions number 7, interpreting and using function notation. The objective is I can interpret and use function notation in tables, graphs, and equations, and we are going to talk about all three of those formats today. So at the very beginning, I'm going to review the classwork in case you weren't there or in case you were confused. We have this great looking graph, and the first question it asks is, what is f of 2? That is a review from the last features of functions paper that we did. And so basically when you see this, f of 2, you have to ask yourself, do I know x? That is going to be a common question. Do I know x? Well, normally we call this f of x. And so when I say, do you know what x is? Well, then I'm telling you that there's an x normally here, but in this particular problem, there's a 2. And so that means that 2 is where x normally is. That means 2 is x. So when x is 2, you're going to go where x is 2, which is here, and you're going to follow that line up and crash into your function right there. When was that? That was when y equals 6. So f of 2 equals 6. Because another way of asking you this is, what is the y value when x is 2? So you go on your function and you find, oh, when x is 2, y is 6. So we're really describing this point in another way. Okay, but I don't want you to write your answer that way. I just want you to say 6. Okay, so for number 2, what values for what values, if any, does f of x equal 3? So if I have written down that f of x equals 3, ask yourself the question, do I know x? I don't. There's still an x there. That means that if I were thinking of this as a point, a location, then I would know the y value this time. The y value is 3. So I'm going to go on my function to where y is 3, and that would be right here. And where did I crash? Oh, when x equals 0. So if f of x equals 3, that implies that x equals 0. Okay, next one, what is the x-intercept? The x-intercept is where it intersects the x-axis, which is this one. And so I see this point right here where it intersects. So your x-intercept is at -2, 0. Okay, again, this should all be review, helping you get ready for the test. But we will get to some new stuff. Here we go on number 5. On what intervals is my function increasing? Well, if I'm thinking about a roller coaster ride going from left to right, yay, then this thing is always increasing. It never turns and goes back down. So it's increasing over the entire domain. And, oh, we skipped number 4 where you were supposed to give the domain. I guess that would help. Let's squeeze in the domain here really fast. The domain is all the x's that I'm using. That says domain. And so I start using x values here, and I stop using them here. Whoa! Bad. Right here is when I stop using x values. And so I am using all the x values in between -4 and 6. So my domain is all the x's between -4 and 6. Okay, when is this function increasing? It's increasing the whole time, so it's going to actually look a lot like that. Although I am not going to put the equals to bar underneath that because it's not increasing at the original beginning point right there. You're just standing there. It's neutral. It's flat. Same at the end. It's not going up or down at that particular point. Okay then, now the next thing that we were supposed to figure out is when. Remember when I asked the question when, I am always looking for x values. So you're going to give me probably a compound inequality to answer this question. When is f of x greater than 3? Well, when is my function values, my y values my function, bigger than 3? Here's y equals 3. But I'm looking for the x value. So I'm going to scan from left to right. And as I scan from left to right, think of this as the laser. Is my black function higher than my pink line? No, right now it's below. But then as I keep moving from left to right, oh look, suddenly the black function is higher than the pink line. That means that my y values of my function are greater than 3, and they stay above the pink line until my function ends at 6. And so in other words, my function is greater than 3 from this point to this point, because that's where this function right here is greater than 3. So I'm going to write that as between 0 and 6. And it is higher exactly at 6, so I could go ahead and put that. But when x equals 0 exactly, they're not greater than 3, it's equal to 3. So that's why there's no equal to bar underneath right here. Okay, next problem. Where? I'm asking the question, where is f of t equal to g of t? F of t, if you read the instructions for that, is the linear one, and g of t is the curvy one. And I'm trying to figure out where are they equal. So f of t is this straight linear one. That's the function f. And then the other one is going to be the function g. So where are they equal? Well, they are equal where they're intersecting. So basically, all you have to do for this is to name the 2 points where they're equal. So -2, -1, and also 3, 4. Those are the 2 places where these 2 functions are equal. Now the next problem, number 9, it says where is f of t greater than g of t, but I want you to cross off the word where and write the word when. Because again, I am asking you for x values, it should say when. When is the function f bigger than the function g? Well, that means in order to be bigger, we're going to have to be higher on the graph, above it on the graph. Because right now, for example, like let's say when x equals -3. When x equals -3, this point right here, -3, 8, is higher than this point down here, which is at -3, -2. So right now, g of t is, what did I say, 8, and f of t is -2. So right now, g is bigger. G is above. And so we're looking for where that's the opposite is true, where f of t is higher than g of t. And it looks like that starts to happen right after they're equal. See that line right there? Right after they're equal. The straight line is higher than the curved line all the way through here until we get to the second point where they were equal. And now the curved line is higher again. So to answer the question, when is the straight line higher than the curved line? That is going to be another interval. And so I'm really trying to find the best way to maybe help you see this, and I hope this helps. If I were to chop this function right here and right here, imagine those are perfectly straight lines, and I am not looking at any other part of it. Okay, we're not looking at that, and we're not looking at that. I'm just cutting all that out. We're only looking at this section in the middle. So then I would say, when is the straight function above the curved function? You would say, well, it's in this whole time, right here, this whole time. It's above. It's above in between, now I have so much stuff written on my thing, I can't read it. Oh, it's in between -2 and 3. That is this interval in between here. Here's -2 and here is 3. That's when it was above. The other places that I shaded red, that's when the curvy one, the nonlinear function, was greater than. So we're not interested in those. We're just describing when, like on a timeline. Okay, number 10. Let's erase a bunch of stuff here. Yikes. Sure, we'll erase everything. Okay, number 10. What is f of 0 plus g of 0? f of 0 plus g of 0. This is a review from when we added two graphs together on the graph on the last homework assignment. So you're going to find f of 0, that's right here. That is the point 0, 1. That tells me that f of 0 equals 1. And then g of 0 is when x equals 0, I'm on the function g, which is way down here at this point, 0, negative 5. So their x coordinates are both 0 right there because I'm talking about on the same column. And g of 0 is negative 5, so 1 plus negative 5 is actually negative 4. Okay, let's do that again with f of negative 1 plus g of negative 1. Okay, so f of negative 1, I'm going to go to the negative 1 column, and my function f is right here. What is that point? What's the location of that point? Looks like I went backwards 1 up 0 to get to that particular point. And this is the origin right here, remember? Then I am adding to that g of negative 1. G of negative 1 is on the curved line, and my curved line hits negative 1 right here. So then the location of that point is negative 1, negative 4. That's a negative. And if I'm adding these together, then, yeah, that was right. F of negative 1 is 0, plus g of negative 1 is negative 4, and 0 plus negative 4 is negative 4 again. Okay, which one is greater, f of 0 or g of negative 3? Well, we just found f of 0 right here. F of 0 we know is 1. F of 0 is 1, and we want to know if that is bigger than g of negative 3. Well, let's go over here on the graph and find it. 1, 2, here's negative 3. That's f, so I'm going to go on up here to g, and I cross when y is 4. So it looks to me like g of negative 3 is greater. Okay, so then the last thing that you need to know for this problem is this new sort of a interval notation. I am actually not going to teach that this year. We're not going to look at it. Hopefully, by the time you get to high school, you'll have intervals down so well that you won't be confused when they introduce this new notation. What I want you to do is cross off that weird brackety thing and write this down instead. Because this is what it means. It means all the numbers between negative 1 and 3. Now, we still haven't done anything. I just was helping you understand the problem. But I am going to, after I clean off some space here, I'm going to cut this function off the way that we did before. So negative 1 is here. I'm whacking it off right there. And 3 is not there. Right here. Okay, so I am not interested in anything over there or in anything over there. We have whacked all that stuff off, thrown it away. We are just looking in between negative 1 and 3, and the instructions are that in between there we are supposed to graph f of t plus g of t. I need to add these two functions together. Okay, so the way we do that is we just march across one at a time. Let's start right here where x equals negative 1. When x equals negative 1, function f was at 0, and my function g was at negative 3. So negative 3, am I doing that right? Yeah, negative 1. Okay, so negative 4 plus 0 is negative 4. Why isn't that working? I think it's because I drew over the line. It's supposed to be negative 4 plus 0 equals negative 4, so we're right there. Let's try it again where we can see what's happening. So now we're going to move over to when x equals 0. My function is here, and my other function is here. If it helps you to write the actual location of the point, you could do that. And then this one down here would be 0 and negative 5. Now when it says add the two together, Oh, okay, well, when x equals 0, I've got 1 plus -5, which is -4, so that's where I am. Start connecting the dots. Okay, now let's look at when x equals 1. When x equals 1, my function is 2 on this one and -4 for that. So 2 plus -4 is -2. That tells me I'm right here. And again, you could connect the dots there. Okay, move on over to when x equals 3. I am adding -1 plus 3. 3 plus -1 is 2, so I'm going to go right back to the... Oh, that's not 2. Here we go. There. That looks more like it. And then we have one more because we were supposed to keep adding all the way up until 3 because this told us to. And so when x equals 3, it's hard to read, but I believe they are both intersecting at 4. So they are both meeting at this point right here. And that means if you were to add 4 plus 4, that is 8. So that function is going to go way up there. And then you're going to add them together. Okay, let's move on to the table on the back. The first question says, what is f of 0? So f of 0, do I know what x is? Same question. I do. X is 0. So I'm going to go down the x column until I get to 0. And when x equals 0, I am actually interested in the function f, which is this column. And so I'm going to go over to this column, and it looks like f of 0 equals 2. I don't really care about the 7 right now because I'm not asking about the function g. So let's do the next one. It says, what is g of -3? So again, do I know x? Yup, it's -3. Going down the x column until I get to -3, and then I'm going to go across to where I'm at the function g, and so g of -3 is -5. Okay, then now the next one, number 16, says, and I'm sorry, we're still on your classwork. I know this is taking a long time, but it's not that hard. It's just confusing. So, where was I? 16. Sorry, I'm eating a sticky candy, and it's sticking my mouth together. Okay, for what values is f of x equal to 0? So we're going to go down the f column until we see 0. Oh, look at that. It happens twice. What is x when f of x equals 0? It's x equals 1 and 2, and that's how I want you to write it. Just give me both of the numbers. Okay. I think what I'm going to do now is to go ahead and jump to your homework. These look like they are from your classwork still, and I'm gonna do instead the ones on your homework that look just like that. Sorry, we're kind of making this up as we go along. Okay, here we are on the homework. First question says, what is f of 2? Do I know what x is? I do. It's 2, so I'm going to go on my x-axis to where x equals 2. I'm going to follow my laser up until I hit my function, and it hits my function when y equals 2. So f of 2 is actually 2. Now the next one says, f of x equals 10. I don't know what x is. X is still x, so I must know y. So I'm going to go on the line y equals 10. That's right here. Now this line, y equals 10, it intersects my function 3 times. You see that? 3 times. Here, here, and here. So what the x is equal when my function hits y equals 10 are 0, 6, and a little more than 10, we could say 10.5-ish. 3 answers. If it crosses more than once, you have to give all the answers. Now, there are no x-intercepts on this function because it never hits the x-axis. So when it says, what are the intercepts, there are no x-intercepts, but you can give the y-intercept. That is the place where it crosses the y-axis, which is at 0, 10. Yikes. Good luck reading my handwriting. Okay, when is this function greater than 2? I'm going to draw the line where y equals 2, and we can look at when it's greater than that. Well, it's pretty much greater than that everywhere except in between here, because that's when it's lower than the pink line. So how am I going to write that? Well, sorry, I have caramel in my teeth. This function is greater than the pink line all the way from between here and here. In between here, it is greater. So how do I write in between there? That is going from 0 to 2. And then it goes below the line a little bit, and then it starts getting above the line at 4, and it stays above the line until 13. This entire section of time right here, the black function is higher than the pink line. So how would I write that? I would write that as 4 is less than x, which is less than 13, or x is between 4 and 13. Okay, I'm going to let you figure out 8 through 12. Turn your paper over and let's talk about the back. It says h of x is 3x. It says g of x equals 3x plus 4. And it says f of x equals 3 to the x power. Okay, then number 13 starts us off by saying find h of 4. Okay, do I know x? 4 must be x. X must be 4. So I'm going to take my function, h of x, and instead of x, I'm going to replace that with a 4, and that is 12. So h of 4 equals 12. Okay, let's do 13b. It says find g of 4. Okay, so I'm going to take my function g of x, and I'm going to replace the x with a 4, and then figure out what it is. And so 3 times 4 is 12, plus 4 is 16. So g of 4 equals 16. Okay, last one of those, it says find f of 4. F of 4. Well, f of x equals 3 to the x power. So f of 4 is going to equal 3 to the 4th power. And 3 to the 4th power is 81. Okay, so those are your answers. All right, last problem I'm going to talk about is number 16. Number 16 says, where, I'm going to change that to be when is g of x greater than h of x? Now, normally I was asking you these on a table or on a graph, and now here I am just giving you equations and expecting you to know. Well, just a little review. H of x equals 3x, but g of x equals 3x plus 4. Think about what this is saying. We're going to take the function h of x, and we're adding 4 to it. When is g of x going to be greater than h of x? All the time. It's always going to be 4 more. It's like having a brother that's 4 years older than you. No matter how old you get, your brother is always going to be 4 years older than you. And so when is this function greater? All the time. For all the real numbers, or from negative infinity to infinity. He's always going to be taller because it's 4 more. So I hope that helps you understand how to do this a little bit. And get ready for your test coming up. Good luck on the homework, and we'll see you in school.